Hello guys, today I'm going to explain mole concept. Now before mole concept, we need to know the differences between atomic mass and the gram atomic mass. Now atomic mass and gram atomic mass. Atomic mass is nothing but the mass of an atom with respect to the mass of a carbon 12 isotope taken as 12U. This is the relative atomic mass. And what is gram atomic mass? It is the atomic mass expressed in gram. Example, if we take magnesium, atomic mass of magnesium is 24U. This is the relative atomic mass which has been calculated with respect to the mass of carbon 12. And this is the relative atomic mass, and gram atomic mass of magnesium is 24 gram. Now, what is the difference between this 24U and 24 gram of magnesium? There is a very large difference, big difference between these two terms. 24U of magnesium contains only one magnesium atom. But 24 gram of magnesium contains 6.022 into 10 to the power 23, which is also called Avogadro number. These magnesium atoms are present in 24 gram of magnesium. Actually, this is the molar mass of magnesium. Similarly, we have another term, that is molecular mass. This is molecular mass versus, I'm writing molecular mass and gram molecular mass. This is the mass of molecule with respect to the mass of one carbon 12 isotope, and it is equal to the sum of the atomic masses of the different elements present in the molecule. Sum of the atomic masses of the different elements present in the molecule. And gram molecular mass is nothing but the molecular mass expressed in gram. This is expressed in gram, molecular mass in gram. For example, let us take one molecule, that is water. Molecular mass of water, relative molecular mass of water is 18U, but gram molecular mass of water is 18 gram. Here also 18U of water contains only one water molecule, but 18 gram of water contains 6.022 into 10 to the power 23 water molecules. So there is a very big difference between these two terms, that is 18 gram and 18U. These are the atomic masses, atomic and molecular masses versus gram molecular mass and the gram atomic masses. Now let's go to mole concept. Mole, what is mole? Mole is nothing but the SI unit of amount of substance. Just like kg is the SI unit of mass, second is the SI unit of time. Similarly, mole is the SI unit of amount of substance. Mole, SI unit of amount of substance. Now, how can we define 1 mole? amount of substance. This can be in terms of number of particles, in terms of mass, in terms of volume. So we can define 1 mole in three different ways. First way is in terms of particles, in terms of number of particles. Now 1 mole in terms of number of particles is equal to 6.022 into 10 to the power 23 particles. These particles, this can be atoms or molecules or ions or electrons or pens. We can say any countable things. 1 mole of, for example, sodium is equal to 6.022 into 10 to the power 23 sodium atoms. And if we say 1 mole of water, since water is a molecule, then 1 mole of water will be equal to 6.022 into 10 to the power 23 molecules. This number is independent of the nature of the substance. And just like in 1 dozen of pen we have 12 number of pens, and in 1 dozen of books we have 12 number of books. Similarly, 1 mole contains 6.022 in 10 to the power 23 atoms or molecules or ions or anything. Next definition is in terms of mass. In terms of mass, 1 mole of a substance is equal to gram atomic mass or gram molecular mass or gram formula mass. This is for atoms, and this is, if the substance is molecule, this is for molecules. For example, we can say suppose 1 mole of carbon, for example, 1 mole of carbon. Since carbon is atom, 1 mole of carbon will contain 6.022 into 10 to the power 23 carbon atoms. And in terms of mass, 1 mole of carbon will have a mass of its gram atomic mass, that is 12 gram. 1 mole of carbon contains 6.022 into 10 to the power 23 carbon atoms, and 1 mole of carbon also has a mass equal to its gram atomic mass, that is 12 gram. So these three terms are equal. 1 mole of carbon, this is in terms of mole, and this is carbon atoms, this is in terms of number of particles, and this 12 gram is in terms of mass. So in terms of volume, at STP, this is important. The definition of 1 mole in terms of volume is valid only for gas, first point, and it is at STP condition. This is nothing but 1 atm pressure and 0 degree centigrade. These are standard temperature and pressure. Now 1 atm is changed into 1 bar, that will give here 1 atm pressure and 0 degree centigrade. Pay 1 mole of a gas will have a volume of 22.4 liter of a gas. This is very important. This definition is valid for gas. Actually this volume 22.4 liter is calculated from this equation, PV is equal to nRT. This is the ideal gas equation, and the pressure will be 1 atm, temperature will be 0 degree centigrade, which is 273 Kelvin, and N will be equal to 1 mole. R is in terms of atm, that is 0.0 0.082 0.082 liter atm per Kelvin per mole. From this particular equation, V will come out to be 22.4 liter. Now if this 1 atm pressure, standard pressure, is changed into 1 bar, which is slightly lower than 1 atm pressure, this value comes out to be 22.7 liter. This is at 1 bar standard pressure. Now these are the definitions of 1 mole. In terms of number of particles, 1 mole is equal to 6.022 in 10 to the power 23 particles, which this number is called Avogadro number. And in terms of mass, this is equal to gram atomic mass or gram molecular mass. In terms of volume, this definition is for a gas only, that is also at STP 22.4 liter. Now we can have problems. Let us take these questions. Now before the question, just we write in short the definition of 1 mole as a revision. 1 mole is equal to Na particles. 1 mole is also equal to gram atomic mass or gram molecular mass of the substance, and 1 mole is also equal to 22.4 liter at STP. This is the definition. Now we take some example here. The first question number 1, solution. Now the question here is calculate the number of atoms present in 44U of carbon dioxide. Now our substance is carbon dioxide. This is a molecule. First of all, we need to know this is molecule, and 1 molecule of carbon dioxide contains how many atoms? 3 atoms. So when we calculate the number of atoms, this 3 is important. Now atomic mass of carbon dioxide is 44. Now what is the meaning of 44U of carbon dioxide? How many carbon dioxide molecule will be present in 44U of carbon dioxide, which is the atomic molecular mass of carbon dioxide. Like I said, 44U is the relative molecular mass of carbon dioxide, which contains only 1 carbon dioxide molecule. So 44U of carbon dioxide will contain 1 carbon dioxide molecule. Since carbon dioxide is a molecule, now since this carbon dioxide molecule contains 3 atoms, 3 atoms, which contains 1 carbon atom and 2 oxygen atoms. This is the answer of the first question. 44U of carbon dioxide contains only 3 atoms. In terms of number of molecule, only 1 carbon dioxide molecule. Now let's go to the second question. Second one is 44 gram of carbon dioxide. Now gram molecular mass. 44 gram is the gram molecular mass of carbon dioxide, which contains how many particles? 6.022 into 10 to the power 23 carbon dioxide molecules. Again, we need to calculate number of atoms present in 24 gram of carbon dioxide, not the number of molecules. Since 1 molecule contains 3 atoms, 44 gram of carbon dioxide will contain 3 into 6.022 into 10 to the power 23 atoms. This is the answer of the second question. This is the difference between U and G. Now let's go to the third question. Third question is, we need to know the number of atoms present in 44 mole of carbon dioxide. Now 1 mole of carbon dioxide, from the definition, 1 mole contains Na molecules. Since carbon dioxide is a molecule, 1 mole of carbon dioxide contains 6.022 into 10 to the power 23 carbon dioxide molecules. Now this is in 1 mole of carbon dioxide, but we need to calculate in 44 mole. Therefore 44 mole of carbon dioxide will contain 44 into 6.022 into 10 × 23 carbon dioxide molecules. This is the number of molecules, carbon dioxide molecules present in 44 mole of carbon dioxide. Now since we need to calculate number of atoms, we need to multiply by 3. 3 into 44 into, let us take it as Na atoms. In terms of number of molecules, this is the answer, and in terms of number of atoms, this is the answer. N is Avogadro number. Now this is the answer of the third question. The fourth question, 44.8 liter of carbon dioxide. Now we know 22.4 liter of a gas NHTP contains Na particles. Therefore, from this definition only, 22.4 liter of carbon dioxide will contain Na, which is 6.0 to 10^23 carbon dioxide molecules, since one carbon dioxide. Let us calculate in 48.8. Now this is multiplied by 2. 48.8 liter of carbon dioxide will have 2 into Na carbon dioxide molecules. Now since again one molecule of carbon dioxide contains 3 into 2 into Na atoms now. That is 6 Na atoms. This is the number of number of atoms present in 44 liter of carbon dioxide at STP. And this is an STP, remember, this definition is valid for STP only. Okay, now let us go to the second question. Second question is, if 100 liter of the gas weighs 200 gram at STP, what is the molecular mass of the gas? Second question can also be calculated from this definition only. We know that it is given here 100 liter of the gas has a volume of how many mass? Is a mass of 200 gram. That is 1 liter of the gas has 2 gram. Therefore, we need to calculate the mass of this gas related to 22.4 liter LSTP. The mass corresponding to this 22.4 liter will be equal to its gram molecular mass, and gram molecular mass is the molecular mass. Therefore, 22.4 liter of the gas will have 22.4 into 2. That is 844 gram. This is the molecular mass. This number is the molecular mass of the gas. Since this is the mass, 44.8 gram is the mass of the gas with respect to 22 or corresponding to 22.4 liter at STP. This is at STP. Since the question is given at STP. Now this is the answer of the second question. Now let us go to the third question. Third question is, atomic weights of A and B. Question number 3. Solution. A has an atomic weight of 20. B has an atomic weight of 40. Now it is given here that X gram of A contains Y atoms. Now the question is, if X gram of A contains Y atoms, then how many atoms are present in 2x gram of B? So X gram of A contains Y atoms. This is the A here. We know that atomic mass of element A is 20, so 20 gram of A contains Na atoms. Okay, this is correct because this is the molecular gram atomic mass of the element. Gram atomic mass has number of atoms equal to Avogadro number, so Na atoms. Now we need to calculate in therefore X gram of A. What will the number of atoms present in X gram? 20 gram contains N atoms. X gram contains X into Na divided by 20 atoms. This is the number of atoms present in X gram of A. This is given as Y here. Now this XNA divided by 20 has to be equal to Y. Now here we have a relation here. Equation number will become 1. Okay, now what we need to do is we need to calculate the number of atoms present in 2x gram of B. So from this equation we need to actually calculate the value of X, because here it is X is 20Y divided by Na. This is equation number 1 here, because we will require this value of X in terms of Y. Now let us go to the third question. The question is B, 2x gram of B contains how many atoms? Now from this atomic mass of B, which is 40, we can proceed as 40 gram of B, which is the gram atomic mass of B, contains how many atoms? Since this is the gram atomic mass, Na atoms. Okay, same definition, gram atomic mass, Na atoms. Now we need to calculate 2x gram of B. This implies 2x gram of B contains 2x into Na divided by 40 atoms. Now instead of this x, we have to put 20y by Na. 2 into 20y by Na. Here Na is here and 40. This Na and Na are cancelled out. This 2 into 20 is 40. This will cancel out with 40 in the denominator. So what is left to us? Y. So the answer of the question is Y atoms. This is the answer. So mole concept is actually very easy, but it seems to be tough. What we need to know is only this definition of 1 mole. From this definition we can make hundreds of questions. I hope you liked the video. Thank you. Please subscribe my channel and like the video.